The next question is how can you prepare cis and trans PtCl2 NO2 NH3 whole negative complex if the trans effect of NO2 negative is greater than Cl negative and trans effect of Cl negative is greater than NH3 negative. In this case we have to prepare two type of the complex, that is first one is cis and another one is trans, and the three different type of the ligands are attached with the metal. First type is Cl ligand, another one is NO2 and next one is NH3 ligand. When three different type of the ligands that we have to attach with the metal to form cis and trans complex. In this case, if we add a ligand of highest trans directing power in first step, here we are having three different type of ligands which are having different trans directing power. So if we add the ligand who is having highest trans directing power in first step, in this case the trans complex is formed. The trans complex will form. And if we add a ligand which is having the lowest trans directing power in first step, in this case the cis complex will form. So let's apply this concept in in this case. So in this case we have to prepare PtCl2 NO2 and NH3 minus oxidation state complex. So let's start with platinum tetrachloroplatinum complex PtCl Cl. Here is also Cl and this is ligand Cl. This is a square planar complex in which the platinum metal is present in the +2 oxidation state. It is having -2 charge. So first of all we will add the transdirecting ligand which is having the highest transdirecting power. So in this case the ligand NO2 having the highest transdirecting power, so we will add ligand NO2 negative. Out of these 4 Cl negative, one will show its transdirecting power, supposed to be this Cl will show its transdirecting power, and this NO2 ligand will occupy the position trans to this Cl ligand. So the complex formed like as PtCl, here is also Cl and this one is also Cl, and the incoming ligand NO2 will occupy the trans position of this Cl. This complex is formed. Now there are two type of the complex. We have to add one NO2, that in this step we have added one NO2. Now we required one NH3. So next step is for addition of NH3. So this complex having two type of the ligand, one is Cl and another is NO2, and the transdirecting power of this NO2 is more as compared to all these Cl ligand. So the incoming ligand, that is if we add the required ligand NH3, this incoming ligand will occupy the position trans to this NO2 ligands. So the new complex will form Pt, here Cl, this is Cl, and this NO2 is present at the same position. The incoming NH3 will occupy the trans position to this NO2, and this complex will become, because these two similar Cl ligand are trans to each other, this complex is trans complex. Let's take the another example. The same complex we will take in the first step, that is PtCl ligand Cl and Cl ligand in -2 oxidation state, -2 charge, which give the oxidation state of this platinum +2. In the first step we will add the ligand which is having the least transdirecting power out of these three ligands, that is we will add the ligand NH3. When we add the ligand NH3, out of these 4, one ligand will show its transdirecting effect, supposed to be this Cl show its transdirecting effect. The new complex formed become as Pt, Cl, Cl and Cl. The incoming ligand NH3 is supposed to be occupy this position, and this complex will become our new complex. We have to add one NH3 and one NO2. So one NH3 we have added. So now in the another step we have to add the ligand NO2 negative. There are two type of the ligand in this complex, one is NH3 and another one is Cl. We know that the transdirecting effect of Cl is more than NH3, and this Cl, out of these 3 Cl, this Cl already shown its trans effect during the first step. So out of these two Cl, one will show its transdirecting effect during the second step. So supposed to be this Cl will show the transdirecting effect in the second step. So the new complex will be Pt, here Cl, here Cl. This one is the NH3 which is already attached. Now the incoming NO2 will occupy the position trans to this Cl, trans to this Cl. This position will occupy by the NH3 and this Cl will remain same. So in this second complex, this is the position occupied by the NO2. The incoming ligand was NO2 by NO2 ligand. So in this case, the similar type of the ligand are adjacent to or neighboring side. So this complex is our cis complex. Next question is, what is the most stable route to form trans PtCl2 NH3 PPH3? This complex, this ligand is also called as triphenyl phosphine ligand. In this ligand, in the center there is phosphorus metal and 3-phenyl ring is attached with this phosphorus. So this will become triphenyl phosphine. This ring is also called as pH. So there are 3 pH attached with this phosphorus. So PPH ki whole thrice. As we know that the transdirecting effect of in this complex, triphenyl phosphine having more trans effect as compared to Cl negative, and Cl negative having more trans effect as compared to ligand NH3, that is ammonia. And we know that we have to prepare trans complex, and there are 3 different type of the ligands. When we are having 3 different type of the ligands and to form trans complex, in the first step, in this case, in the first step we will add a ligand which is having the highest transdirecting power. So let's first take the complex PtCl4, PtCl, Cl, here is also Cl and Cl. This is the square planar complex in -2 oxidation state. In the first step we will add the ligands which is having highest transdirecting power, that is triphenyl phosphine PPH ki whole thrice. Out of these 4, one ligand will show its trans effect. Supposed to be this Cl show in this case its trans effect. So this PPH3 ligand will come trans to this Cl. The new complex will form as Pt, Cl, Cl, Cl. The incoming ligand triphenyl phosphine occupy this position PPH ki whole thrice minus oxidation state. We have to add one triphenyl phosphine and another NH3 ligand. So in step number 2, we will add the ligand NH3, ligand ammonia NH3. So this complex having 2 different type of ligand. One type is Cl and another type is triphenyl phosphine. Out of these 2 type of the ligand, the trans effect of this triphenyl phosphine is more as compared to Cl. So the incoming ligand NH3 will occupy the position trans to this triphenyl phosphine ligand. The new complex will form as Pt, here Cl, here Cl, and triphenyl phosphine ligand is already present at its position. The incoming ligand ammonia will occupy the position trans to NH3 ligand. This complex is our trans complex. So suitable route is, in first step we will add the ligand triphenyl phosphine, and in second step we will add the ligand NH3, and our starting complex will be PtCl4 2 negative.